Okay, let's go with this one. So, weighted mean, we talked about a weighted mean, but this is now a mean and frequency distribution, very similar. We're good? A weighted mean was kind of like the general aspect. Like if you have a weight of something, like a unit value, you have to consider that virtue. Okay? How we do in statistics is just like this. And let me give you a quick example first. If you want to write it down, that's fine. But notice that you got 2 repeats of 5s, right? You got a repeat of 8s. So instead of doing the long way, here's the long way. All right, if you want to write it down, that's fine. If you don't, that's fine too. Work with you can. This is my little exercise about means. So the old way would have been 5 and 5 make 10. Add 8 more makes 18. Add another 8 makes 26. Add another 8 finally makes 34. How many numbers do we have? We have 5 numbers here. So I'm going to do is I'm going to take not 10. Math teacher can't do math here. So 34 divided by 5, anybody? 6.8, everybody agree there? 6.8. So I'm going to do it like this then. Oh, no. You have to help me out with the math here. 34 divided by 5, and I heard a 6.8. I agree. We're good. Cool. Let's jump to the other side here. So instead of counting the 5 and 5 all over again, right? We have, let's say this was a midpoint of a class. So 5 is a midpoint, A is a midpoint. Super cool. So all we got to do is just take the frequencies of them. There, I have 2 5s. I have 3 8s. So instead of just starting to add and add and add and add, I'm going to multiply first. Multiply it over here. And I'm going to add the x times f column gets me 34. Okay, talk to me. Am I adding up the class midpoints or am I adding up the frequency? What number did it divide by the first time around? With 5. Which one adds up to 5? Yeah, it's the frequency. So I need the frequency added up. So that actually makes sense, right? Isn't a frequency how many times something happens? So if you add up the total number of times something happens, that's the total number that you've had happen, right? That's cool. So I just take the 34 over 5 and voila, I get my answer. We good? So with frequency tables, we multiply the midterm times the frequency to more quickly. Can we do it the old way? Absolutely. Just takes an awful lot more time. Good. So let's do an example here with it. Right. Jump to this. This is how you do it. That's fine. And an example how to do it, and then we'll actually do it. So this is the out-of-pocket expenses frequencies. So notice it's the midpoint right here, right? Multiplied by how many times that happened, right? You do this, numbers kind of get large here. You add this up, add the frequency. Don't need to write this one down. It's going to take a long time. And then we take this divided by this. So we get ourselves. So the average was 287.7. Okay, your job. Here it is. Given a sample of group data, can you find the cost of textbooks or the mean of the sample for the cost of textbooks? Gotta do some calculator work. Good. This one you write down. I'll give you guys a little bit of time. Do it yourself. So first things first, you do have to find the midpoint of that first. There. I'm going to step out just for a little bit. Again, work with your neighbor. You guys, real quick here. How do you find the midpoint of the first one? Absolutely. Divide the limits, right? The class limits. So real quick, let's do this one together. If you have a calculator, ready? 140 plus 179. And then divide that by 2. What do we get? $151. 159. Okay. Sure. I don't know the answer yet. I just kind of put it up there here. So 159.5. I got a 159.5. Anybody want to second that? Okay. So the midpoint of the first column is a 159.5. Okay. Okay. You guys get to the rest. I'm going to step out and see if I can contact this person. Okay, one full poem done. Okay, let's go with it here. You guys talk. This is 159.5.
Yeah.
Jacob, are we good with that? 159.5? Yeah. Okay. Give me the others, guys. Go for it.
199.5.
Okay, anybody see the pattern? Yeah, look at this. Remember the class, what was it called? It was called the class. Right, was it class limits that they were called, right? Yeah, class boundaries, remember extended to just right to the end of each one, right? But class limits were just little pieces there. So notice this guy goes up by 40 each time, right? 40. This guy should go up by 40 here. So I'm going to take a wild guess here. 239.5, is that right? Yes, 279.5. Help me on the next one. 319, okay. 359.5. 399.5, are we good there? And the last one. 5, perfect. So, okay, with that said, oh shucks, we actually need to make a new column, huh? Yeah. Okay, this is x times f. Okay. So we need a column that does that. Okay, help me out. Hope you guys have done it already here. I need a multiplication of these guys. And you know what? I gotta tell you, those that don't like to work with numbers, don't go into stats or engineer or accounting. If you like working with numbers, this is the tediousness of numbers right here. Show of hands real quick here. And I say, man, this is actually pretty fun. You like multiply stuff, put these together, put on one side of the ledger, put on the other. 2, okay. I say, you know what? Not for me. This is no tedious work. Multiplying here, trying to put this number here. What the heck? Okay, I got 4 honest people here. Okay, how many say like, oh, it doesn't matter. Hey, it's okay, whatever. Okay, in a minute. Okay, help me out with calculator. What is the multiplication? Say it slowly so I can write it down. Okay? So 159.5 times 4. Exactly 638. Okay, perfect. Yep. Give me the next one. Oh, you know, I'll do this one. Okay, good. You know, I'll do another one for you guys. Okay, that's it. Okay, the others. 239.5 times 4. See? 958. And please be okay to correct another person if you need to. Just say, hey, I think I got something else. That's fine too. 279.5 times 6. $1677. Does not like to do this. Let's give the answers to this. Okay, so they have a conscious desire to do this stuff, Sarah. Okay, 359.5 times 6. Just a little louder. 2,000.
2,157.
Oh, sorry, I got to raise down here. 2,000. 100. 157. Okay. Just speak just a little bit louder here, just so I got it. So 399 times 5. 700 even. 799. Okay.
Oh, sorry.
That's okay. That's what we hear. That's how usually in statistical work. Usually have like 1 or like 2 or 3 people doing the same stuff. Just the numbers. 139.5 times 3. 13. so much. Okay, guys, the tough part here is the addition of these two columns. So if you do the frequency column and then 36, okay, good. And the tough part, good. 10,942 exactly. Or actually, you can't see dollars, right? Okay, can you, anybody second that last number there? Second to last number of 10,942. Second that, okay, awesome, that's perfect, okay, so this is a sample mean, okay, so let's do the notation correctly here, it should be X bar instead of median, right, you would be the population, so we didn't look at every single cost of textbook, every single textbook in, and depends, are you looking at a college, right, are you looking at a state level, actually, are you looking even in the discipline, right, like all the math textbooks at that college. That could be your population, right? It could be all the textbooks at the college. It could be all the textbooks in California. So you got a wide range of stuff. Okay, so I got 10,942 divided by 36. And the answer is exact answer or approximate answer? You guys get approximate. So I'm going to go like this here. I'm going to put AB equal signs, right? That just means approximately, and give me to the nearest. Actually, no, we gotta go to the nearest dollar and cents, right? Because it's the value here. So give me the nearest dollar and cents. Exactly 3 or 4? Yeah. Oh, nice. Okay. Boom. Okay. Did you guys get exactly 3 or 4 or 309 point blah blah blah?
Yeah.
309 blah blah blah. Okay, so I think maybe that way, yeah, 3 or 4. Okay, guys, good. It's a concept. I didn't want to spend extra time on this one because this is the one that sort of you rush through it, so you sort of like so. I hate that. Okay, there is that. Done, done, done. Next is just a quick conversation in regards to shapes of graphs. So this one we're going to pick back up in chapter 6, but this is called symmetric distribution, all the different shapes of distributions you can have. So these are just like a preview of things we're going to encounter in chapter 6 and 7. I think chapter 6, I'm sure chapter 6 as we get into this here. So this one is a symmetric distribution. This is what we love to see right here. This is awesome. Everything is balanced. The mean, especially this right here, the mean, median, and mode are identical. Now, when we say identical in statistics, they're just like maybe just tiny bit off, but for the data set, it's nice. And this is called a normal distribution. And there's a sneaky way to get to a normal distribution. Find out in chapter 6 how we do that. It's pretty cool. It's pretty cool. The person that thought of it said, like, hey, I can get all practically anything into normal distribution. And then the question is, where is the normal distribution compared to another normal distribution? All right, so here it is. So what is a symmetric distribution? Is the fact that I can draw a vertical line right through the middle of the graph of this distribution. And the result is I pretty much have mirror images one to the other. And what else that happens is the mean, median, and mode are all the same. So the bunching up is right in the middle. Because it's symmetric, you know, the median is there. And as an average, all these guys up, because they're balanced on each side, you know the mean is also the same spot. And the same spot, that means like super duper close to 8, right? Compared to this distribution. Okay, that's 1. The next one, and tell me if I'm going too fast, we're good? So if you want to draw it out and stuff like that. This one we are going to work with because it comes up. Probabilities or later on. Uniform distribution. Everything is happening the same. And again, in statistics, it's a relative term slightly. It's like almost the same. And so the distribution is pretty much even across the board. So all entries or classes in distribution have approximately equal frequencies. When can this happen? You test something. It doesn't have to be with numbers. Could be with categories as well here. But we look at numbers here. Maybe off the cuff example here, like students' favorite food in the cafeteria, right? As you do that, you find out that there's no really hard preference. Everybody's about the same. Grade distributions in a math class. I don't think that's going to go uniform. Sorry, did you have a question or?
Yeah, I'm just confused.
Okay, go ahead. Unconfused with questions. Go ahead.
Mentioned something about ready to math class, so
Oh, gotcha. A lot of times, this is not the way it is. Maybe just a
for like skill level for math or something like that.
maybe that'd be good. Or maybe a particular skill level as you dig down into your data, you find out, oh, for this group here, everything's about the same. Oh, then you're thinking about that. Okay, so a uniform distribution. We have a whole bunch of math. Once we see that, we're like, oh, cool. There's a whole bunch of math that goes along with those kind of distributions. Okay, and then it is also symmetric as well, right? So if you cut it down the middle, still the same on both sides, as opposed to the next 2 shapes that we'll actually look at next. Okay, let's jam this one. Okay, so this one we call a skewed left distribution. Now, when you say skewed left, what you mean is the tail itself is on the left-hand side. So you look at the tail, not where it kind of bunches up. I think your eye naturally goes to where it bunches up, right? That's at least what my eye does. Like, hey, it's bunched up to the right. So then what happens, it is actually left skewed or negatively skewed. So if you right there, I just put skewed, look at tail. So when you do that, look at tail. Okay, what happens here is the mode is where it occurs the most. So it's up on the right-hand side. And then what happens, the median is shifted a little bit less than that. And then what happens, the mean is shifted even less than that because the average is still going down towards the left. So you can either write it the way the top right is written. Normally, we write it the second way, the underlined way. So mean is going to be less than the median, which is less than the mode. And that is a good sort of view of things. You look at the mean, look at the median, look at the mode real quick here, stat crunch it real quick, and you say, oh, that's happening. And you know that you have data that's a little bit skewed to the left. Okay. 2 more people writing down, go for it. Bam, next one here, and that's kind of what we talked about there. The other way, of course, is right skew distribution. So somehow we couldn't get it in the middle. Tried a few things, still think of this in the middle. It is a right skew distribution, which means the tail is on the right-hand side. There's more of a tail towards the right, and the exact opposite thing that's happening. So the mode is the first one. The median is slightly shifted to the right from the mode. And the mean is slightly shifted to the right of the median. Again, we'll really pick this back up in chapter 6. Yeah, it was good. I don't know, but I should know more about this weekend. I'll take the time this weekend to sort of things up. I know we shifted the date. Yep. Plus, we'll know after how fast we get through 2.4. That's the big section. That's the limits. For a while. Okay, are we good there, guys? Let's do this. Can we jump into 2.4 for a little while? We'll go for a little while, and then we'll take a break once our brain is a little bit heavy. So all 2.3 was about is the fact is how do you find the center, right? That's it right there. How do you find the center? 2.3. We did mean, median, mode. And we also did this little weighted mean for frequency distribution. So are we good there? Does that make sense in your mind? There's like 3 things plus the stuff that you have when you have frequency distributions. 2.4 now deals with how much variation, how much spread do you have? And we think like, oh, that's easy. You just take the biggest minus the smallest and you're done. Not quite as easy as you think. Okay, but that is one of them. So let's jam with it here. So the first one is the obvious one, the range. Yeah, to figure out how much spread you have, absolutely. Take the biggest value you have, subtract it, subtract by the smallest value you have, and you're done. You have your range. What's wrong with that? Nothing. Just doesn't give us enough information sometimes. Okay, let's go with it then. Let's see which example should we use. Now let's go here. So we got two different corporations. I want to do both of them. That's fine. These are starting salaries for graduates. Find the range of the starting salaries. So it looks like corporation A goes from 41, 38, 39, blah, 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 blah. Starting salaries for corporation B is this one. So you're choosing which company you want to be a part of. And then there's a lot more factors, right, than just the salary, but one of them is the salary. Just had a fun story here. Since I graduated from Fresno State, there was a statistics on people that got starting salaries for communication majors. So good from Fresno State. Forget the year. The year is important. It was like $85,000 a year. Anybody want to start off with $85,000 a year? Like, sure, yeah, that depends. Okay, the only problem is there was all the other people were starting at $30,000, right? And this other person was starting at $450,000 because that was the year that David Carr graduated from Fresno State, and he went on to the NFL right away, right? So his salary bumped that mean on, all the way to 85,000. So isn't this like that's the problem right there, right? The mean is that one. Like, man, everybody should become communication majors, right? Like, no. Let's look at the data a little bit more. So, anyways, for you guys, go for it. Can you find for me the range of corporation A? That's it. Just a quick little example. Of A, corporation A, should be really quick here. Figure out the biggest number, figure out the smallest number, subtract when you're done, and the answer is 10. Are we good? Biggest number is 47. Smallest number is 37. So we're good there. It's just 10. So the spread is 10. In fact, that was easy. Can you guys do corporation B as well? What's B? Anybody? 35? Are we okay with 35 or 25? No, 35, right? 58. Subtract 23. A lot more spread in corporation B, huh? Okay. So is it a good statistics? Yeah, it's useful, right? Initially, just to find out stuff. So do we think there's more spread in corporate B? Absolutely. In fact, let's jump to it real quickly here. That's kind of like my little thing. There's our 10 for corporation A. So there's a range of $10,000. But really, to get sort of the crux of it, that's what we need to see, visual representation, right? And once you see a visual representation, then you're like, oh, I got it. Okay, so which one is it better to go into? Corporation A, corporation B? Jocelyn says A, how come A? Yeah, there's actually more assurance that you probably will get into that little higher category, right? If you're in the weight water, right? If you come with more experience, right? You have experience behind you, at least, then you might want to look at corporation B, right? Because if you did an internship and you did some other stuff, then you're like, well, come on, my experience is going to give me a higher salary. I think I'm going to just try for corporation B. There's that. Okay. Boom. Next is this whole concept right here. This is the good stuff. So the range just tells you high to low. What we want to look at is deviation. So deviation just means how far are things away from the, oh, there's our mu again. What is mu again? Mu is the mean of our population, right? Yeah, it's the average. So, oh man, look at this. Two different formulas again. One is for population sets, right? And one is for sample sets. You got these two different, again, it's just notation difference here. As we get into the formulas, there actually will be a formula difference actually. Okay. Deviation is how much things deviate or move away from the center or the middle or the mean in this case. So even though we still like to use the mean. Mean is just such a good number because it's you can calculate it real quick here, right? It's computational, so we like to use the mean, even though we understand that it is prone to outliers. All right. Population of the set. Deviation from x would be x minus mu. Deviation of the sample set would just be x minus x bar. Of course, we're going to calculate some of this. Okay, next, some writing here, guys. Some writing here for you guys. Okay, so that's the first set. That's the deviation. Now let's get to the formulas. They're huge, but we're going to break them up just like we broke up the weighted mean formula. We're going to get that. So formulas, here they are. For the population, variance formula looks like this. Instead of, again, don't get too boggled with all the notation, and it's just notation. It's just yeah. We'll kind of break it up into pieces, and we'll do it so it doesn't get all crazy. So, but notice that little x minus mu right there. That's the concentration. So that's the difference away from our middle, our mean. What we do is we square those guys. We add them up, divide by how many n values we have. And that is something called population variance, used sometimes in certain tests. But the more popular one is something called standard deviation. So notice the two differences in the formulas. The bottom one, the standard, is just a square root. So it's not really two different formulas. It's just variance gets you to one level. Standard deviation just says take the square root. So same formula, same everything. You just take the square root of the top formula to get standard deviation. Good. Sure. Okay, so let's kind of think about this here. I guess we should, yeah. Let's do this here. Let's write down the stuff about it first, and then here's some lots of writing. Don't want to scare you guys here. How about this? So you have to write down everything. If you want to, the standard deviation measures the variation of the data set about the mean right here. It's like up to here, up to the mean. Highlighter. Yellow and yellow. Up to here. This one is important. This one we've got to kind of think about. That one's important. Okay, so I was able to chop down just the first one. All right, so first things first, let me sort of talk as we go through this here. So first thing is the standard deviation. What does it mean? What does it do? It measures how much variation or spread you have around the average or around the mean. That's the one thing. So it's concentrated about the mean. How much concentration or lack of concentration you have around the mean or the average. Next thing, just if all sides we have the standard deviation equals 0, what in the world does a standard deviation equal 0 mean? Yeah, all the data points, not so much as they have just barely any variation, they're exactly the same. It's 5, 5, 5, 5, 5, 5, 5. That's it. So that means obviously the third point. That means if 0 means no variation, that means a small number means low variation, right? And then a bigger number just means more variation. So as the number gets bigger, that means more of the values are spread out. So it's a spread out number. That's what it is. Once we get really into like a lot of data stuff, like chapter 6, maybe we'll probably do that. And good question. Yeah, I don't want to. So here's the thing. I don't want to. I would rather do like small amounts of data and see where the numbers are coming from, as opposed to like here's a calculator, here's a bunch of you know how to plug in the calculator all the time, but you have no clue where the numbers are coming from. So there are teachers that teach it that way. That's just way wrong because we never understood the concept of things. Yeah, which is a useful skill. I mean, you have to know how to use a calculator. I'm just thinking if you know the concepts underlying the calculator, then you can use StatCrunch, you can do a lot of different, right? You're not tied down to a calculator crunch. But do you know how to put letters on here? Which letters? Ah, alpha. All right. As we start writing essays on this calculator now. Okay, let's jam. Okay, that's the. I think that's the longest one that you guys have to write stuff in. But does that make sense? You guys good? One is you're just talking about the mean. That's what we're talking about, and how far you are measuring away. 0 means all the data points are exactly the same, and small variation means you're just barely moving away from the data, or you're moving a lot further away from it. Okay, so real quick here, let's go back. Can you guys, real quick, not last, but all. Hey, you guys, let's go back to this data here. Corporation A, we're going to focus on this guy. Can you guys give me quickly the average, the average for this guy? Average. Say again? Nope, not the range. We already figured out the range was 10 grand. I want the average. Okay, you guys talk to me. What do we do to find the average? Add them up, divide by. Divide by 10. Cool. Add them up, divide by 10. Let's see what we get. Tell me when you got it. Cool. I get a 41.5. Everybody second that? Cool. We get second, third, and fourths. Okay. So average is 41.5. You guys ready to keep that in your mind? 41.5. Here we go. And we are jamming all the way here. Zoom. Oh man. Sorry guys, we have a table on our hands. Can you guys make a little table? And I gave you the salary inputs right here. We got to do it vertically because vertically makes a lot more sense than doing horizontally. This is tired of writing. So take a time, make a table.
Did you happen to have any like scratch paper?
Yeah, absolutely. I have not lined paper, but like computer paper. Okay.
Anything is cool. Sure. For some reason, I still haven't got myself a notebook.
Okay. Give me whatever you don't need after the response. All right, you guys good? Okay, so next column is x minus mu. What was our mu again? 41.5. So here's what we need to do. Now, don't write the formula if you don't need to. Here's what I do when I actually do statistics. What I'll do is I'll write down the formula first right here. I'll put 41 minus 41.5 and I'll write the answer. But then afterwards, I just write down the answer, right? So the first column kind of gives me what I do, just in case I forget, because a lot of times there is the, what was I doing in this column? So 40 minus 41.5 means that this guy is half. It's in thousands, right? So $500 less than the average. That's what that means. But we're doing thousands, so negative 0.5. Okay, next one. What is 38 minus 41.5? Okay, you guys get the rest. Go for it. So this is put down the answers the way you got them. Go for it. You'll see a pattern happening as well, and that's cool too. The reason why sometimes they put salaries from like smallest to largest is because sometimes you have root values, right? Then you can just put down the same number. So like the more organized the numbers initially are, usually is a lot better to organize it in. If you see any numbers repeat themselves, obviously you can put the same thing. Like I think if 41 repeats itself twice more. All right, so as you guys are done, we're going to go off this list here real quick. The numbers are going to work pretty good on this one. And let me get to you in just a second here. That. Absolutely nice. But I like that one. So on those ones. That was for the just square the zero, negative 0.5, just square that. Okay, there's one more extra thing also. Yes. That's we're going to talk about that. That's huge, man, huge that comes up. All right, let's see. I'm going to go down the list. You guys tell me if you guys got the same numbers I did. Here it is, negative 2.5. That one. I'm going to say it. How about this? That, and that. Okay, everybody good there? I don't see anybody with an eraser or scratching out their pen markers. So that's good. You guys are all good statisticians here. Okay, next. Notice the next column. It says x minus mu, but now it's squared. Notice the previous column is x minus mu. So it's not, we're not going to multiply across. We're good? Not weighted mean. We're going to just square the previous column. So on your calculator, real quickly. Oh, I should say this real quick here. Now we'll talk about later. Let's go with it. Square it. Tell me the number you guys get on your calculator. Just kind of do it. Let's have a class discussion here. So this is negative 0.5 squared, and you get. Okay. Let me get some more answers here. Tell me what you get. Do shout outs here. What you guys get? There's some funky stuff happening. You got like you touching something again? Just take that all out. So we're not taking the square root, we're squaring it, which is the exact number. Take the number. Oh, there's square is this guy here. Okay, guys, real quick here. Let's talk. Don't write this down yet. Don't write it down. Because real quick here, this next answer, half the students in statistics get it wrong. You guys ready? So give me some answers. 0.25, give me an answer. 0.25, any other answers? Thank you. There it is. There's your two answers. And usually half the class has this one, half the class has this one. Let's talk about it. If I'm squaring this, and I count it from my calculator. If I go like this on the calculator, if and if it's square, it's going to give me that guy. That is the wrong answer. That's what we want to do, is we're trying to square this whole thing. So whenever you square something, this guy always looks at the number in front and squares it. Okay? It leaves a negative outside. To include the negative into the number, you have to. That happens. Now that 2 that's squared is actually on a negative. So the correct answer is positive 2.5. Okay?
Point.
Are we good? Okay, so these guys, so we could, let's talk about this here. We can do one of two things. Good? You can always include the negative, and you always include the parentheses. We good? Or you say to yourself, you know what, Mr. MG, I'm super smart. If I go negative times a negative, I know this has to be positive, right? So on the calculator itself, instead of just putting in a negative, you just toss out the negative. Just put 3.5 squared is, and you go from there. You good? Okay, good lesson on the thing that trips up stat students right there. So final answer is, I did have it like that. Okay. One thing I should note here, guys. This little column right here. See how it's made up of like some of them are negative, some of them are positive, right? If you do this correctly, this is the stuff away from the mean, right? Which means half the stuff are on this side, and half the stuff are on this side, right? Half the stuff. In fact, let's count how many. Interesting. There's 6 negative numbers, 5 positive numbers, right? But notice these 2 5 positive numbers, they're way higher. We don't get a. We have a negative 4.5, but that's a 5.5. That's way high. Okay. All this to say, sorry. If you did this and you add this up, the answer should be 0. Because it's balanced, right? It's balanced from above the mean and below the mean. Okay, so this number, look like this number doesn't mean anything to us, except for the fact that you want to check it to see if it's correct. Okay? Because it just says we're balanced from above the mean and below the mean. Okay. Now this one right here. So 0.25. So officially, if you want to do it the purely mathematical way, you include the negative. But if you understand this 3.5 to the second, it's fine. Anybody, what is the second answer? Perfect. Yep, 12.25. And notice all these guys are going to have non-zero answers to it, right? You can't have a negative in your squares column. All right, 2.5 squared is 6.25. I know that because 25 times 25 is 6.25. Oh, this one's a repeat. This one's a cool repeat. This one you guys shouldn't get repeats now. So this one has to be a 12.25. This is a new one. 5.5 times 5.5. 30.25. Perfecto. This one is a repeat of my original one. 5. This one's a repeat of the negative one above. 6.25. This one's a repeat of the original again. Thank you. This one's a new one. 20.25. Okay. And this one's a repeat of this is the negative of the original or opposite original. That's easy enough. Boom. Okay, we're almost there, guys. Let's go with adding all this up now. No fun, Mr. Geo. Sorry, guys. So you guys talk to me, what is the addition of all these things? What's that E stand for? It's not an E, it's a Greek letter S or capital S, and it stands for sum. So it's the sum of all the x minus mu's. Good. No problem, you guys. I understand even like when I learn, I understand that as I listen to a lecture, there's a piece of the lecture I forget. Because I forget, then the rest of the lecture is kind of like not making sense now. So if you need to go back and ask those clarifying questions, that's why you guys are sitting in class. Really good. That's why we're having a, in my mind, classroom should be a discussion classroom, right? A discussion of what you don't know to what you know, where you want to clarify and put things together. So answer. 88.5. Can I get a second on 88.5? Perfecto. And third and fourth. She was. Okay, we're almost done. So this one, the way we label it, because it's the sum of the squares, it's just notation, guys. This one we just put SS, capital S, capital S. It's not just the sum, and then we use now we actually use now we use American letters, right, for that one. Why the different notations? Because they came in different time periods. That's why. Different time periods. And now that we had computer systems, and then we were able to number crunch stuff, so therefore it came in that's kind of works. Okay, not to confuse you yet. On the next slide, let's go over this. So I want to know the population variance. So if you want to label this, just so you have it for your notes, label it as, this is called sigma. This is the lowercase s in Greek. Lowercase sigma here. So sigma squared, that little 2 that actually does mean squared. And this stuff right here is all the stuff we've been working on right here. This is a whole entire last slide. Look at this. Didn't we have an x minus mu column? Didn't we have an x minus u squared column? Yeah, did we add all of those guys? Absolutely. There's my 88.5. It came from all these, finally the 2 columns answer. And there are 10 numbers there. That's perfect. These ones, normally you are going to have to all right, the variance is good, 8.9. It's pretty simple there. Now, this one, the important one here. So you got to talk about this population standard deviation. So what we do is, okay, here's the tough part. You guys ready? Notice for, if you're trying to figure out the population variance, you just chop it off as 8.9. Okay? If you're trying to get to standard deviation, you want to keep as much consistency as possible. Good? So, yeah, so the bottom one, notice on the bottom right here, it doesn't take the 8.9 and kind of shift it down and take the square root. We don't do it that way. It takes whatever this actually the precise answer, which was 88.5 over 10, it takes that value and does that. Okay? So kind of be careful here. Because if you go like, oh, I got an answer of 8.9, I'm going to take the square root of 8.9, I'm going to get this. And these will be off a little bit. Does that make sense? Easy working. Okay, let's do just one more. Then. Sample standard deviation, because it's the same thing. I'd rather do the same thing So it connects in our brain here. So same exact equation. Now we're talking about samples, sample variance, sample standard deviation. And you guys just real quick, before we start writing down the formula, tell me what is the difference between the two equations?
Squared and one squared.
Ah, good, good. One is the square root of the other. Perfect. Next is, what's the difference between this one and look at your notes, the population variance equation. Perfect. Yeah. So real quick here, notation. This guy, right? One had a mu in there, right? This one has an X bar. Any computational difference between the two?
S.
Oh, yes. Instead of Greek letters, we're using English letters now. So it's S instead of S. Or sigma.
Minus.
Yes, okay, the main one. You guys ready? Notice on the bottom, it's n minus 1. So whenever you take sample variance, sample standard deviation, we always subtract 1 from the total number we have. The reason for it is because we have sample and error. This is one way that we try to figure out how to undo sample and error. So it's n minus 1, and I must assure you, but I hate to say this, one or two of you guys are going to divide by n instead of n minus 1. So whatever you need to make clear in your mind on the test, say, look, divide by n minus 1. Put a sticky note saying, for samples, it's always how many you have minus 1.
We can have like a study guide for the test.
You guys will be given a study guide for the test, yeah. The way the study guide works for me, and we'll talk about it next time, is I give you guys the instructions, the exact instruction of the test. You just don't see the numbers. So then you know exactly the instruction. So it's like find the sample variance. You know that exactly there's going to be a question says find the sample variance on that. So then you go back to your homework and you look at some homework questions that are very, very stimulating. Okay, so let's do this one real quickly here. Okay, everybody done writing? Let's jam. Let's do one real quick. Just skip all this, skip all this. Let's go to here. In a study. Oh, once you say study, of high school football players that suffered concussions. You guys do that? Is there such a thing? Anybody football players that played in high school? That played in high school? Football in high school? No. You did? Yeah? Did you ever have a concussion? Say again? So say again, you didn't have a concussion? Oh, gotcha. Okay, okay, cool. I'm glad you did. Yes. Oh, ouch.
Sorry.
I was wondering, how are you doing?
What's that?
How are you doing?
It's a great day.
Yeah, how's volleyball? Maybe, how's volleyball going?
It's all stats. It's all stats.
Who are your like best players on the team?
Once you get out of here, it's not new.
Is there any player that you have concern about?
Well, was it because they're math class, maybe?
Yeah, okay.
Yeah. Yeah. Just doing homework. It's just doing homework. I think you just do your work.
Thank you so much. Absolutely. Because the homework is, if you get the homework and you understand the homework, you pretty much got the concepts down. It doesn't matter how to study for tests.
It's like going to practice. If you skip practice every week, you're not gonna get better.
Absolutely. Totally agree.
I'm a gamer though, so on game day, I got that. Watch me.
Not gonna happen.
There we go. There we go.
I remember all the great basketball players, right? Magic Johnson, Irvin, they would walk around with the basketball in their hand because eventually it was the tactileness.
Yeah.
So by the time they finished high school, they've, what do? You bounce the ball, right? So they have so much practice that the ball was part of that. And I thought that's kind of interesting.
Yeah, I'm glad that was that TI, what is it, 65 or
84?
84? Yeah. Oh, yeah, 84 plus?
Whoa, it's a plus even.
All right. Enjoy the rest First grade.
Thank you so much. That's it. Okay, players recovered from concussions, 14 days or less, replacing group 1. Those that took longer, replacing group 2. The recovery times and days are in group 1. So these guys are the ones that took less than 14 days. This is a study, is that correct?
Yes.
This is not all the high school football players in the United States, right? In California. It's not even all the high school football players on the same team, right? I don't even know that, right? So in this case, it's a sample. So let's find sample variance. Obviously, what we're going to do, of course, do this little area here.
Right.
Writing it down, yes. I'm not going to make you 2 of them, but let's just do 1. These guys. Now we'll take a break after we keep this one. That'll be, so just hold this concept of range and standard deviation. Switch gears. One, two, three, four, five, six. All right, as soon as you do that, then I do have the sum on the bottom that 90 is actually useful. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 units. So when you guys get that, give me the X bar value. Give me the average of the X bar. X bar is percent. Sample mean. And then do a little bit of that little new thing. This one has excellent population. It's just all right, let's talk about this here. I got 90 is the addition of all those guys here. What is the mean? What's the sample mean yet? Anybody? What is the sample mean of the data? 7.5. Everybody do 7.5. Anybody else? Anybody second that? 7.5? Like, what are we doing? Second. Okay, good. Okay, real quick here. So we're just trying to find the sample mean. This is the average. We're just trying to find the average. How do you find the average? You add up all the numbers.
Yeah, 7.
Perfect. Add up the numbers. How many numbers do we have?
90.
That's the total.
12.
We have 12 different numbers, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 90 divided by 12 gets you 7.5. Okay. I didn't write it on the screen. I should write it on the screen. What I should? So X bar for us, X bar equals the summation. If you want to write down, do like a notation person here, over N. And us, the summation of all these guys is 90. There are 12 different numbers. Punch that into your calculator, and you should get a 7.5. Then the fun begins. We're going to go back to our list here. Now it's going to be 4 minus 7.5. What is 4 minus 7.5? Second. 83.5. Awesome. What is 7 minus 7.5? Negative 0.5. Perfect. 6 minus 7.5. Sweet, negative 1.5, it's 1.5 units lower. Hey, the 7 repeats itself. That's the easy one. Oh. 9 minus 7. 1.5, right? 1.5. All right, and go down the list. Once you're at the bottom of the list and you're like, you know what, Mr. Angie, I got this. I understand this. Then fill out the last column, which is the squares of each of those. Out of curiosity here. Like like the person that tried to call me, they finally texted me saying they couldn't call me. For some reason in this room, I can get in cell phone service whatsoever. Okay. Go anywhere. I get it like right here in this lawn, right over here.
Yeah.
That's it. All my phone calls are in the lawn. Okay, let's check our answers. Here's what I got. Okay, trivia question. You guys ready? Trivia is, if I were to add up my deviation column, what would the answer be?
Not that.
0. You get 0. Deviation column, you get 0. Is that right? Do we need to calculate that? Heck no. Don't need to calculate that. Okay, square them. Let's go for it. Square them. And I'm going to walk around and see where you guys are at on squaring them. With let's see, some people are done. Some people are halfway done. Some people are starting. Some people need just help. Okay. Remember, this is just like the last one. Forget the negative, because you know it's going to be positive anyways. So your calculator just punch in 3.5 to the second power. You get 12.5. This one again, we've done this one before. 0.5 squared is a 0.5. Let's see the same numbers over and over. 1.5 to the second, which should give us a 2.25. This one is a repeat already had before. Hey, that one's a repeat already had before. This one is 25. I just know this 25 times 25 is 625, so it's 625. That one's a repeat. That one is 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 a repeat, and that one is a repeat. That is so cool. So really, I had to do one calculation. Right. From our repeats from the previous column. Okay, now, if you guys can, give me the summation. Sum of the squares. For this one, nearest 10 is fine. Yeah. That's what we want. That first. Okay, sum, anybody with the sum of squares? 31? Oh, I got 39. Anybody second 39? 39. 39. Okay, awesome. 39 it is. Sweet. So Edwin, question, go.
All we did was add them up, right?
Yep, So notice there's no, this is the thing, when you square something, you get rid of negatives, that's exactly what we want to do. Because if you're 5 units away from the middle, on this side, 5 units away from the middle, on this side, it cancel out, right? But by squaring it, you pretty much computationally got rid of your negatives. That's what you want. That's what you want. Okay, and let's go with the rest of it here. So if you want to write in the notation, so you have it. So s squared, lowercase English s squared. Ooh, you know what? There's a notation issue here. That should have been like a little 2 here, right? There's a 2 that's missing here. I'm gonna write that in. Yeah. There. As well. Okay, 3.5 is good. Roughly 3.5 is the variation, and 1.9. Really quick. I know this is kind of weird, but let's see which one has more variation, the football team stuff or our corporation A? Last one had variation of, or standard deviation of 3. This one has a 1.9. So again, not even trying to think of the data as a whole, but just the data itself. This one actually has less variation. With that, let's take a break. Let's see. Let's go 15 minutes, then we'll come back. That'll be 11. And someone's working on something.